Okay, today we're going to be talking about section 4.1, and we're going to be talking about parent functions and how they all work and what they all look like. So the very first thing we're going to talk about is what a parent function is. A parent function is the simplest form of a family of functions, and it's basically I give you many different types of functions, and you automatically need to come to mind what those functions look like graphically. So the very first one I give you is going to be x is equal to y equals x. That's a linear function, and I'm going to make this bigger so that you guys can see it a little bit here. And probably turn this more at an angle for you guys. There. Okay, so it's a linear function. So when it's a linear function, that means you are literally going to have a line on your screen, okay? Absolute value is y equals the absolute value of x. That is going to be whenever you have a mountain or a valley, okay? The next parent function is going to be x squared, which is a quadratic. A quadratic is the shape of a U or a horseshoe. Then we have y equals x cubed, which is our cubic function, and I call this your spaghetti function. Why? Because it literally looks like a piece of spaghetti thrown up against the wall, okay? And our last one is going to be the one-armed bandit, which is our square root, and that is basically where we just have a parabola turned on its side on one arm of it, okay? Those are the 6 functions that I need your brain to memorize, and whenever I say what is the parent function, you need to say y equals x, y equals absolute value of x, y equals x squared, y equals x cubed, or y equals the square root of x. Those are parent functions. Generally speaking, p of x represents a parent function, okay? Now, we talked about this briefly before, and we talked about what it means to have stretch, compress, reflect, left and right, okay? Same exact concept here. I give you this wonderful little function. Every one of those signs and letters does something different to the parent function. The negative reflects it over the x-axis when it's on the outside. The a, when it is greater than 1, when the a is greater than 1, it stretches it and turns it into a travel mug. What do I mean by that? Let me get my travel mug so that you can see what I'm talking about here. It changes your coffee mug that you normally have into a travel mug and makes it very long and lean, okay? When your A value is going to be between 0 and 1, it turns your coffee mug into a compressed cereal bowl and stretches the arms out and puts all the trash clear up against the sides of the trash bag. That's a compression, okay? Then, if the negative is on the inside of the parenthesis with the x, it's reflected over the y-axis. So anything that is over here now goes over to the right, so x is replaced with negative x, okay? And then this h moves it back and forth left and right, and then the k moves it up and down, okay? So if the x is on the negative on the inside, it's reflected over the y. If the negative is on the outside, it's reflected over the x. It's always the opposite direction of what you think if you're going left and right. If it says minus h, you're actually going to the right. If it's plus h, you're going to the left. And the plus k and the minus k is exactly what it looks like. Plus k means you're going up, minus k means you're going down. This is your cheat sheet. You need to keep it with you and use it the entire time, okay? So let's describe the transformations. And we talked about this previously, up, down, left, right, stretch, compress, reflect. We're going to keep doing it. So what is my parent function? My parent function, I'm going to look right here and look at the power, and my power is going to be a 2, so therefore it is going to be an x squared as my parent function. The vertical shift means I'm going to go ahead and grab this number right over here, so it means it's going down 12 units. The horizontal shift means I'm going to be looking right inside here, that's a minus 1, so you think it goes to the left, it's actually going to the right one. The stretch or compress, you may only have one or the other, okay? That is a 3. That 3 is larger than 1, so it's a stretch of 3. Is it reflected? Do you have a negative on the outside or a negative on the inside? No, so you write none. And then maximum, minimum at the y value, vertex, axis, symmetry, and range. Now, so basically what I want you to do is I want you to think a little bit. Is this thing opening up or is this thing opening down? Well, the 3 is positive, so this thing is going to be sketched okay? My vertex is the point 1, negative 12. So I'm at 1, negative 12 down here. And I am not reflected, so therefore I'm opening up. So therefore I have a minimum at what y value? At negative 12. My axis of symmetry is x equals h, which happens to be the value 1. And then we're going to read this function from bottom to top. My range. I start to hit this graph at the y value, negative 12, and I go all the way to infinity. And I can be the value negative 12. Okay, so that's basically what we're doing today. So let's go ahead and do that all over again. Same exact thing. Now, I'm going to cheat, and we're going to do this the way we're used to doing this. We're going to read this thing from left to right and make our life a little bit easier, and we're not going to go in the order that you see here. Because then, after you go from left to right and you know that you're done with everything, you simply put in none for all the ones that you haven't used. Now, this right here really jacks with your brain. It says negative 6 plus 4. Many of you are going to want to combine that. You cannot do that. What your brain needs to understand is this is actually 4 parentheses x plus 2 squared minus 6. The minus 6 goes at the end, and that is the up and the down shift. So let's read this thing from left to right. The 4 stretches at 4. The plus 2 goes to the left 2 units. The minus 6 goes down 6 units. The parent function happens to be x squared. And we went through everything. 4, 2 squared minus 6. We did everything. What that means is it is not reflected. And if I go ahead and make a sketch of this thing, the very first thing I want to do is find the vertex. The vertex is hk, which means left is negative 2, down is negative 6. So I'm here at negative 2, negative 6, and it is not reflected, so therefore it looks like a U, which means it has a minimum value, and that minimum value happens to be the y coordinate of that vertex. And then my axis of symmetry is x equals h, which happens to be negative 2. And then my range, I'm going to read this thing from bottom to top. So where do I run into this graph at? What y value? Well, the y value is the minimum, so that's going to be at negative 6, and it's going to go all the way to infinity. Okay? Let's keep on going. Same exact thing. Again, this says 5 minus 3 over 2, parentheses x minus 6 quantity squared. If this jacks with your head, what I want you guys to simply do, and I'm going to unlock this, I'm going to move this over here, and I'm going to lock that back up. Okay, and I'm going to rewrite this. This is the same thing as negative 3 over 2 times x minus 6 squared plus 5. Why plus 5? Because the 5 was positive, so therefore I had to keep it that way, okay? So reading this function from left to right, it is negative. The negative is on the outside, so therefore it is reflected over the x-axis. 3 over 2. 3 over 2 is a fraction, but is the fraction larger than 1? Meaning, is the numerator heavier than the denominator? And then the answer to that is yes. 3 over 2 is 1.5, so this is a stretch of 3 over 2, not a compressed. Be very careful. The minus 6 is going to the right 6 units, and the plus 5 is going to go up 5 units, and we know that this is the parent function, x squared. So that means I can sketch this graph. So if I sketch this, the very first thing I want is the vertex. Going to the right means positive 6, going up means positive 5. So I'm going to start at 6, 5 right here, and this thing is reflected over the x-axis, which means it is opening down. So that means I now have a maximum at my y value. My y value is 5. And my axis of symmetry is x equals 6. Now we're going to read this thing from which direction? Bottom to top, which means I start at negative infinity, and where do I top out at? What y value? The y value is 5, and that's why I have a bracket there. Okay? Let's do it again. Which direction are we reading this from? Always left to right. So negative 0.2575. What does this mean? It's negative, so therefore it is reflected over the x-axis. 0.2575 is a fraction, but it's actually a decimal. But ask yourself, is it between 0 and 1? The answer to that is yes. So therefore, this is a compress of 0.2575. The plus 3 means I'm going to the left 3 units. The minus 25 means I'm going down 25. And then this lovely little power of 3 tells me it's the power of 2 tells me it's a quadratic, x squared. So I'm going to go ahead and graph this function. And I'm going to first look and graph the vertex. The vertex left is negative 3, down is negative 25. So I'm at negative 3, negative 25, all the way down there. Okay, well, this thing, I'm now going to look at my reflection. My reflection says it's reflected over the x-axis, which means this thing is opening down like a horseshoe. So since it's opening down like a horseshoe, I have a maximum value at my y-coordinate of negative 25. My axis of symmetry is x equals negative 3, and I'm going to read my range from the bottom to the top. So I'm going to run into this thing at negative infinity, and I'm going to go all the way up to my maximum y value, which is negative 25, and it can be that value, which is why it is a bracket. Last example, and then we're going to go straight to your homework here. Read this from left to right. The negative on the outside says that I'm reflected over the x-axis. 2/3 is a fraction between 0 and 1, so it's compressed. Minus 1 means I'm going to go to the right 1. X squared is my function. Minus 12 means I'm going to go down 12. I graph this thing. I go to my vertex. Right is positive. Down is negative. So I'm at 1, negative 12. I look at my reflection, and it says that means I'm reflected over the x-axis, so I'm opening down. So therefore, I have a maximum at the y value, negative 12. The axis of symmetry is always x equals h. H is 1 here. And I read this thing from bottom to top. I start at negative infinity, and I go all the way to my maximum y value, which is negative 12, and it can be that value. Tonight's homework is 4-1, worksheet 1, transformations and range.